I would like to thank Patrick and the organizer for the invitation. Also, I apologize that I'm not going to write I didn't write the chapter because I found that, in 4,000 words, it was very difficult to put together all the necessary information. And within the last 6 months, there have been 57 review publication on the same topic. So, I hope I will satisfy you just with my presentation. So these are my disclosures. And so, first of all, the first step is the accumulation of fat in the liver, which is not a completely unphysiological mechanism. It is a physiological storage mechanism. And when the fat starts to accumulate in excess, this is due to increased lipogenesis, increased lipolysis, and here there is a major role of the visceral adipose tissue. This leads to decreased beta oxidation, and luckily, these free fatty acids are esterified in triglycerides, which are a good storage system, but then we will see that this may not go over a limit. So the natural history of Nash or NAFLD is very well known. There is a large part of the population that is characterized by fatty liver. Fatty liver means something that is detectable by ultrasound that corresponds to about 30% of hepatocyte containing fat. And we assume that 25% of people with fatty liver will develop a form of inflammation and progressive fibrosis. This is also not completely clear. Also, it is unclear if there is a balance in the same subject of period of Nash alternated with period with simple fatty liver, or it is one-way progression. But it's clear that there is more or less a 25% progression up to one stage of fibrosis every year, up to cirrhosis, and finally decompensation. As you all know, the number of patients labeled as NASH cirrhosis requiring transplantation has increased. Actually, they appear from nothing because 10 years ago they did not exist, so maybe we were not doing a right diagnosis. There is also a risk of hepatocellular carcinoma as for any form of cirrhosis, although for NASH, like for hepatitis B, there is a possibility of developing HCC before reaching the stage of cirrhosis. So I will give you my view that is not necessarily true, or is basically what I think about the whole process. So in the process of accumulating fat in the liver, I see two phases. There is a phase of adaptation where most subjects adapt to have more fat in the liver. And for genetic reason, I think, and also for lifestyle, this adaptation may last all life, so you can have a fatty liver all your life. Then we go to a phase when adaptation is not anymore efficient, that become pathological, and then you have the what we know as non-alcoholic steatohepatitis. Just to give you an example, this is a study we did at the Royal Free where we look at the biopsy of about 350 patients which were referred for suspect of NASH, but in the end they had only fatty liver without signs of inflammation or fibrosis. And what we see here, there is this FPA is like fat proportional area, is the amount of fat which is verified by morphometry, by an automatic system. We go from less than 5% to more than 20%. And with the increase of fat in the liver, and here we don't have any inflammation and fibrosis, there is a progressive increase in the size of hepatocyte. They go from 273 to 442. And at the same time, there is a progressive decrease of hepatocyte in the lobule. So as the hepatocyte become bigger, the number of hepatocyte in the lobule decrease. So how this happen? So one of the mechanisms of this is likely to be autophagy, is the recycling of material without making damage. And maybe many subjects, they have a very efficient autophagy, so they can achieve this goal. But many other subjects, at some point, this became a very strong predisposing condition for oxidative stress, and then they develop NASH. Indeed, there is a beautiful article, review article on the Journal of Pathology January issue. It's called Autophagy in Hepatic Adaptation to Stress. Autophagy is present in all chronic liver disease. In particular, in this case, is autophagy which is due to metabolic overload. And if you see on this side of the slide, there are negative role and protective role for autophagy. But in the first phase of non-alcoholic fatty liver disease, it is likely that autophagy is mostly protective because it has a strong anti-inflammatory and strong antioxidant property. So if you have a good autophagic system, very likely you may not develop NASH. So this is something to keep in mind. Then when adaptation is finished, we go into pathology. We start to see necrotic hepatocytes or apoptotic hepatocytes, inflammation, and progressive fibrosis. Fibrosis in non-alcoholic steatohepatitis is not the same fibrosis as you see in viral hepatitis or in cholestatic liver disease. As you know, it is a pericellular fibrosis starting in the central lobular area with initially a chicken wire fibrosis around hepatocytes, and only lately developing septa and developing as irregular cirrhosis. But for many, many years, fibrosis is only in the central lobular area. This is a very quick cartoon from normal liver to NAFLD. You have the hepatocyte with fat undergoing apoptosis. You have activation of all the non-parenchymal cells. Stellate cells become activated. They become myofibroblasts. Kupffer cells become strongly inflammatory cells. The sinusoidal endothelium is becoming no more sinusoidal, but irregular endothelium also with pro-inflammatory properties. Also, over the past 30 years, we have known a lot about the activation of stellate cells. Once stellate cells become activated, they start to proliferate, they become contractile, they are fibrogenic, and also are unable to degrade the extracellular matrix. So this leads to a completely changing microenvironment in the liver. So the extracellular matrix is not the same as the one in normal liver. Also, another important point that is reflected in clinical, for example, by measuring stiffness, is that the liver tissue becomes very stiff because of increased contraction and cross-linking of the extracellular matrix. And in addition, this matrix is full of growth factor. A cytokine is like a landmine field. So every cell that goes to this area will activate further and become more inflammatory. So in clinical terms, and Pierre Bedossa may kill me for this, but I still believe in this. So we go from a stage of simple fatty liver, then we go to the inflammation and fibrosis called steatohepatitis, and then we go to cirrhosis. On the other hand, we observe also cases where we have steatosis with fibrosis without much evident inflammation. And this could be just an intermediate stage that then go back into the full-blown NASH picture. But there is evidence that in some patients, this stage, this mild stage of disease may develop slowly to cirrhosis. So the point here is, does an entity called steatofibrosis exist? And this is very important when we look at like drug target. So if this exists, we need to consider that antifibrotic will be more important than anti-inflammatory. And the point is that fibrogenesis in NAFLD may be partially independent of cell necrosis and inflammation. So here, I'm going to make a breaking point. This is what people think about fibrosis in general. There is an injury. The injury is chronic. There is an activation of a chronic wound healing reaction. The best solution is to develop a scar so that tissue can stay together. This is not, in my opinion, the case of NASH. I would cross this because it's a very superficial view. Instead, if you go back to the picture that I showed you before, there is a stage which is called adaptation, where there's the passage between simple fatty liver and NASH, where there is no evident necrosis. So if there is no necrosis, there is no wound healing, because there's nothing to wound. In this phase, there is defective autophagy, there is lipotoxicity, oxidative stress, and genetic factors. And still you can develop inflammation and fibrosis without the presence of necrosis. And then you have a phase where there is evident necrosis, and here, yes, there is a chronic wound healing reaction. At this point, you have many other things. You have increased intestinal permeability, so activation of the inflammasome. There is the establishment of complex inflammatory networks, which are partially repair and partially immunological, and also there are genetic factors. So the mechanism of fibrosis in NASH depends very much from the phase of the disease. First of all, lipotoxicity. So lipotoxicity is basically due to the fact that there is a huge inflow, excess inflow of free fatty acid to the liver. And these are phosphatidic acid, lipophosphatidic, and so there are several of those. They have targets, and they lead to the so-called lipotoxic liver injury that is typical of NASH. So there are effectors of the free fatty acid and ceramide, sphingosine, and so and so, and the targets are mitochondria, which become dysfunctional, lipid droplet. Autophagy can be actually damaged by free fatty acid, by lipotoxicity. So in a second phase of the disease, even if you had efficient autophagy, this can be disrupted by free fatty acid. On the other hand, oxidative stress, it is an important determinant. It's probably the first mechanism relevant together with lipotoxicity and in combination of lipotoxicity. If you do a staining for Heme oxygenase, which is a gene redox sensitive, so it's activated in any condition of oxidative stress, you see that you have staining both in hepatocyte, cholangiocyte, but also in stellate cells. Basically, all the cells of the liver respond with, to oxidative stress. And this is common not only to NASH, but also to hepatitis C, as has been detected in most of chronic liver disease. So here, how do these reactive oxygen species arrive to the cells? There is an increased release from inflammatory cells, damaged or steatotic hepatocytes. There is, because of this cascade of cytokine activation of NADPH oxidase called NOx, the NOx family. This is an important target and is autonomous producer of ROS. And then this leads to mitochondrial beta oxidation that produce more ROS. Then there are many other determinants, for example, intracellular iron, so a high iron level are often associated with NASH. There are also other determinants, for example, in hepatitis B, in hepatitis C, there are nuclear proteins that also activate this pathway. So in the end, there is a production of reactive aldehydes, which are thousands times more reactive than ROS, and this leads to a response. For example, this is a very old paper from my lab from the 90s, showing that if you take human hepatic stellate cell and incubate with reactive aldehydes at doses which are present in a pathophysiological process, this hydroxynonenal and this octanal and undecanal, you have a very strong activation of collagen, procollagen 1. So oxidative stress can be directly profibrogenic without needing inflammation or necrosis. Also, there is a variability in individuals, how we react to oxidative stress. So here you have production of ROS, either external or coming from NOx. So if you have low level, which was basically, for example, when you drink 2 glasses of grappa in the evening, you have an activation of this NRF2 that leads to an antioxidant response. So basically, you respond to the stress, and the next day you recover the mechanism for when you drink again. But if you drink two glasses of grappa every 6 hours, you go to intermediate level, and this leads to a pro-inflammatory and adaptive response with some protective anti-apoptotic. And if you have very high level of ROS, this will lead to apoptosis and necrosis. So it depends, this adaptation is depending on which level of oxidative stress you reach. Also, I mentioned there is activation of the inflammasome, and part of the inflammasome is toll-like receptor system. And in obesity, diabetes, or patient with Nash, there is increased intestinal permeability. So there is these pumps. The most common is LPS, but about 1,000 of those. They can go into the portal circulation and interact with stellate cell on toll-like receptor 4, and automatically, without need of inflammation or necrosis, they induce a profibrogenic response. So this is another inflammation and necrosis-dependent mechanism. There are genetic factors, and there are many of those, but I will concentrate on PNPL3, which is a very good example. The mutation of this protein is associated with increased severity of liver disease and also with increased incidence of hepatocellular carcinoma. This is a first paper from Francesca Bruschi, who was originally in our lab in Florence and then worked with Michael Trauner in Vienna, that she showed that this protein, the expression of the protein increased with the activation of stellate cell, and if it's silenced, there is a reduced activation. And also the presence of a mutation in this protein gives to hepatic stellate cell a very strong pro-inflammatory profile. These data were, this is a summary of this finding. These data were produced, however, cultured in stellate cell on plastic. And so in London, we have upgraded the system in 2 ways. First of all, every stellate cell preparation that we do from section or surgical section we get from surgery, we do a genotyping. So we have stellate cell with mutation heterozygous or homozygous. So right now we have about 45. So we have a community of different cell preparation. And so these have been characterized. This is an allelic discrimination plot. So we have the wild type, we have the heterozygous, and we have the homozygous. So what we have been studying, the gene expression in the 3 categories. This is the control, the wild type, and this is the homozygous. You see the big difference between control through the heterozygous and the homozygous. So there is a huge genetic difference. There are about 686 genes which are differently activated in the mutated form. And then the second upgrade is that instead of culturing the cell on plastic, we make scaffold from human or cirrhotic liver. This is how the scaffold look after you remove all the cells. And we did experiment by culturing the cell in scaffold of a healthy or cirrhotic liver and then stimulating them with TGF-beta1. So what we see here, these are the 3 most relevant proteins. Cytoglobin is a marker of quiescence. If you go into homozygous, this marker is disappear, meaning that the cells go into full activation. VARS2 is a mitochondrial protein for the beta oxidation. As you see here, that if you go into the cells which are homozygous, they have a markedly less expressed capability of working on beta oxidation compared to the stellate cell. And glutathione S transferase is very important. Antioxidant system is completely disappeared into the homozygous. So basically, the mutation promotes the activation of the cell through a dysregulated oxidative stress response. So subjects with the mutation have a further decrease in their ability to respond to oxidative stress. These are all the cells involved, the crosstalk involved in fibrogenesis. I highlighted platelets because platelets have been shown recently to have a key role in the initiation of an immune mechanism in Nash. And this is one of my old passions is chemokines. and it's a very complex system. But just to show to you, and there is one drug that is addressing, a drug in phase 3 addressing this CCR2, CCR5 network. So a good way to reduce inflammation is to find out molecules which are involved in different sites of the inflammatory process, from adipose tissue to stellate cell to adipocytes. And there is no surprise that this strategy seems actually to work. And this is upstream of fibrosis, actually targeting inflammation. A confusing point is that although fibrosis in NASH is the most relevant predictor of negative outcome, when we look at endpoint in clinical trial, the impact on fibrosis is only considered in 17% of the trial. So we still like looking at disappearance of fat, of stabilization of NASH, which don't make any sense to me if you don't consider that fibrosis is the outcome. And another thing, this is updated. There is and Arun Sayal, I think, will go through this. There is a pipeline of drugs which is completely crowded in phase 2, but only 5 drugs are promising in phase 3. So I think we are still in a phase where we are shooting with a machine gun into the jungle without knowing what we are hitting. So I think we need to have a bit more insight to go more thoroughly to what we want to target. And this is people have collaborated to the study. Thank you very much for the.
Thank you, Massimo, for this fantastic overview about the physiopathology of NAFLD NASH. Is there any question in the room? You have the microphone. Yes, Pierre, you have a question. Microphone, please. Alors, where is the microphone? Yeah, it's coming.
Thank you very much, Massimo, for this brilliant talk. I have 2 questions for you. You addressed the issue of steatofibrosis, and we shortly discussed about that. If you consider that that NAFLD is a disease that wax and wane, why the steatofibrosis should be just a marker of a past event of a boost of NASH and only a sort of cicatrice, how do you say, a sort of sequela of this episode, rather a marker of the progressive disease? And my second question, if I may, is we don't see a lot of apoptotic bodies or necrotic bodies in NASH. We see ballooning cells. And as you are talking about ballooning, and as you are talking about pathophysiology, what are ballooning cells?
Right. So thank you very much. I mean, this is we can have a full meeting on this. But my point of view, I agree with you. I mean, it could be like inflammation that, for some reason, is in a phase of inflammation can disappear quite rapidly, and fibrosis, it takes much longer time. So you can have a situation where you have fat and fibrosis because it's like inflammation has disappeared, at least temporarily. But my point of view is that oxidative stress alone, can cause fibrosis. You don't need inflammation. So there must be some kind of compromise, a way between this process. So I believe that there is fibrosis. There may be fibrosis, at least in the early phases, without need of a wound healing or inflammatory reaction. So something to keep in mind. And I agree with you that compared to hepatitis C, where you have clear necrosis, and then the wound healing reaction is obvious. I mean, hepatitis C is a typical wound healing situation, chronic wound healing. In NASH, and this reinforced my concept, the ballooning and this aspect of cellular degeneration are more associated with NOx activation, with ROS production, with lipotoxicity consequences. So they go into an inflammation that is probably not driven by the wound, is driven by all these factors which are very strongly pro-inflammatory. So I'm not sure that the presence of fat or the amount of fat correlates necessarily with inflammation. It depends from individual to individual how they handle autophagy, how they handle oxidative stress, and how they also handle, for example, TGF-beta biology, because each one of us has a different, may have a very strong TGF-beta response or not TGF-beta response or very mild. So there is a lot to understand there yet. So when we talk about drug targeting the early phase of the disease, it's still as I said before, shooting in the wood without knowing if you're hitting a rabbit or a pheasant. So it's a bit like this.
Patrick, a question?
Massimo, beautiful presentation, thank you. It seems that HCC occurs in NASH patients earlier than in other chronic liver diseases as compared with, okay? It seems, I'm not completely sure. But if this is the case, what could explain that the promotion of the cancer occurs before the occurrence of cirrhosis at F2 or F3 stage? Do you have any hypothesis?
Yeah, this is a very important point that doesn't have a real answer, because we can go back to oxidative stress. If you read a chapter from 1970 about liver cancer, you will find that the only mechanism is oxidative stress. But I think there is a main issue, and we don't know this very well, in the tissue damage that is present in NASH. What is the pro-regenerative response? So each chronic liver disease has a different way of targeting a possible regeneration. And the more oxidative stress or the more lipotoxicity you have, it's very likely that the regenerative response becomes more and more abnormal. In hepatitis B is a different story. There is an integration of HBV genome within the DNA, and this leads to pro-oncogenic signal. In this case, it's more the microenvironment that is pro-cancer, is not something inside the hepatocyte. But, although it's still debatable, because, it's not that everybody agrees that HCC is present in non-cirrhotic in NASH. But definitely, I think we should look at the aberration in tissue regeneration that are typical of this condition.
Okay, last question from Philippe Mathurin.
No, I just want to come back to the fact of how we are looking at this data, and I completely share your comment with regards that you can have fat and have fibrosis progression. We have the same data in our sample population on 2,000 patients. F2 steatosis, pure steatosis without inflammation is 20% of them. Same data from Pierre that has been published in Gut across the table, and I find out the same thing. And when you go to the paper from Angulo, big cohort, again, you look at extensive fibrosis, and we are coming back to, I completely share the comment that fat is not a benign thing. The disease progression is lower, that's for sure, as compared to NASH. But when you consider the number of candidates, you have a higher proportion of pure steatosis as compared to NASH. So at the end of the end, I don't know where they are. Same thing, by the way, in alcoholic liver disease. We considered 40 years ago when I was young, never at that time in medicine anyway, that steatosis was considered as a benign. But now what we know in alcoholic liver disease, 20% of extensive fibrosis is related to steatosis. But steatosis alcoholic is faster progression so now. So I think we need to find, at the beginning, I completely share the comment, probably the issue is fat if you want to target the initial stage, because otherwise I think this disease will not progress. That's my point of view. Maybe I'm wrong, but I'm sharing your comment.
Thank you.
Thank you for coming.